So we're continuing on with our study of can you tell someone's height from their voice. We just rejected the null hypothesis. Looks like you can predict some part of height from voice. And now we're going to compute a confidence interval to see exactly how many of the 100 pairs a person is able to judge correctly on average. So we'll use the usual 95% confidence level. We have 24 observations, so we have 24 observations. So the degrees of freedom is 23. So we have those 24 values of how many they got correct. And then we'll compute a t-star for degrees of freedom 23. For 95%, 2.069. We have to look that up in the tables. And then we'll use the interval formula x bar plus or minus t star s over root n that we had for t intervals. The mean was 54.125. There's the t star, 2.069. S was 6.72 and n was 24. Remember, that's this plus that number and this minus that number. That represents an interval. Here's the interval that gets created. It's 51.287 up to 56.963. So clearly above 50, but the range of values we have there, it could be as small as, almost as small as 51, or as big as maybe almost 57. 51 we might not find that astonishing that you could tell a little bit. 57 though seems like a bigger number, so with that small a sample size, we don't have a very good idea what the long-term mean is going to be. But we can tell it is above 50. On to our next topic after that. We want to look at a situation where you use t. T is often used in matched pairs experiments. Okay, so we'll think about matched pairs. Matched pairs is when you take the subjects and you pair them up with like characteristics. Then you administer the treatment to both in the pair, and you see if the two treatments, if one treatment is better than the other by randomly assigning the treatment to each pair so you don't accidentally assign it in some kind of consistent way. And you look at the response variables in the pair and see if you see a pattern of one treatment or another treatment having a larger response variable if that's what you wanted. To analyze the data, we find the difference in response variables. So we take the two values from treatment 1 and treatment 2 and we subtract in the same way for every pair. Use those values, the differences, as our sample, and then perform a t-test using the differences. And then the null hypothesis mean is mu naught, which is the usual long-term mean of the differences. So we're trying to give it evidence against the difference of the values, long-term being some number. Lots of times that's 0, because we're looking for the pairs to show a change or to be different. And so the null hypothesis is that the pairs really are the same. They have the same long-term mean, so the differences would on average be 0. And then for your alternative, depending whether you're looking for a decrease, an increase, or just a difference, you'd have mu something, mu naught sitting there. Now if mu naught was 0, then you'd have mu is really less than 0, greater than 0, or not equal to 0 as your alternative. So we'll go ahead and do one of those in a minute, and getting close to finishing off this chapter.